Hello and welcome to Starborn Science. Today we will be talking about flash powders and I've chosen samarium as I do not have any other reactive metal. Well, for now that is. So I got an ampule of samarium . And filed off 200 milligrams for 2 tests with my homemade chlorate, which I will also show you in another video how to actually make it. But now let's focus on the reaction. The chlorate ion has a negative charge as the potassium ion has a positive charge, so the whole ionic compound has a neutral charge. So since oxygens always have a -2 charge, that of course tells us that the chlorine atom has a +5 charge. So we have 6 oxygens which are -6, so -6 plus 5 gives us -1. Samarium +3 oxidation state, so of course what happens here is the samarium gets oxidized, meaning over here samarium goes from being neutral to losing 3 electrons over here. And these 3 electrons that each atom of samarium loses goes to the chlorine atom of the potassium chlorate and reduces it to chloride, which has a -1 charge. And went up with samarium oxide, which of course I'm not gonna draw geometrically correct. And this is the whole reaction. And of course, as you can see, there are no gases, there's only solids. And we'll explain this further. So, let's say we have our flash composition here and we ignite it. The reaction will propagate through the flash composition in milliseconds. The electron transfer will happen, which will be the samarium will be oxidized to samarium oxide, and the potassium chlorate specifically the chlorine atom, will be reduced into chloride. The potassium cation is just a bystander, it does not matter. So what's gonna happen is that the reaction is just gonna propagate through the mixture in milliseconds. After that, what's gonna happen is that the heat of the reaction will create a very hot plasma which will flash heat the atmosphere around it, causing it to rapidly expand from all the surrounding environment into a bubble and expand outwards, and that will create a pressure front, and that pressure front will propagate through the surrounding environment to your ear, registering as a loud bang or a pop, depending on the reaction speed, meaning how fast the flash powder reaction is taking place. So if the reaction is slower, you may hear a pop. If the reaction is really fast, you may hear a bang. So let's see what happens now if we confine the flash powder. So what I want you to remember from this explanation is that flash powders, in contrast to any other, most other energetic compounds or mixtures, do not produce any gaseous products. They take advantage of heating the atmospheric air, and if they are confined or really fast burning, they result in an explosion or in a loud report or a pop due to the rapid expansion of the atmosphere that is being flash heated by the speed and heat of the reaction. So keep that in mind. Here I have a small quantity of samarium and potassium chlorate. It's about 50 milligrams of samarium and 50 milligrams of potassium chlorate, and I'm going to ignite it. I'll turn the lights off so you can see the actual flash and why it's called the flash powder. It was used in the early days of photography to actually produce a flash in order to take photographs in the dark. As you saw, it made a pop and it burned rapidly and very hot. And here's another test. Fuck me. Now, if you confine the flash powder, meaning if you put it inside the container, what's gonna happen is that when the fuse burns, and reaches the flash powder, it will ignite it, and the air inside the container will be flash heated, as the flash powder will instantly burn, and it will be flash heated and it will expand rapidly. However, since there's no place to go, it will keep trying to expand, increasing the pressure in the container until the container fails. And when the container fails, it will burst open, releasing the gases, and that will result in an explosion, registering as a loud report in your ears or in my camera microphone, as I will demonstrate in a while. So now let's see what happens when you confine flash powder. Over here I have a paper cylinder with two caps consisting of cotton and cyanoacrylate with a titanium wire running through it, and in here there is 50 milligrams of samarium powder and 50 milligrams of potassium chloride, with the other half of the cylinder being atmospheric air. Here is an illustration of it. Here is the flash powder, here is the air, the cylinder, the two caps, and the titanium wire. What is going to happen is that I'm going to use my capacitor bank and send the high voltage pulse through the titanium wire, which will vaporize it and will ignite the flash powder in milliseconds, which is the relay closing time, which is 15 milliseconds, and we'll see how the flash powder behaves when it's in an enclosed cylinder, which is called confinement, and it will result in a loud report, meaning a bang. So this is a quick rundown of my capacitor bank. It has the stored energy of 220 joules, which is equal to dropping 1 kilogram of weight from 22 meters. So it's equal to dropping 1 kilogram of weight from a third floor story building. So all this energy is being dumped through a tiny titanium wire in 15 milliseconds, which is the closing time of this high power relay, which of course handles the power discharge as a normal relay would weld its contacts or fail, and this other system controls the high voltage transformer, which charges the capacitors, and another relay which of course discharges the capacitors through this 1 mega ohm resistor for safety reasons. And now we are ready. I have my earplugs on, so one, charging the capacitors. Capacitors are fully charged. Going to a safe place. 3, 2, 1. So that was a bit more energetic than I expected. So that was all from me. Click like if you liked the video. Don't if you didn't. Keep dreaming, keep exploring, and I will see you on the next one.